Hi students, in this video we are going to solve problems related to the concepts we learnt. The first question is, if the Cartesian equation of a plane is 3x minus 4y plus 2z is equal to minus 5, then reduce it to the vector form. First one, what we need to do is, we need to compare this equation with the Cartesian equation of the plane. Cartesian equation of the plane is, as you know, ax plus by plus cz is equal to d, where d should be non-negative number. But here d value is equal to minus 5. In order to make it as positive, we will multiply both sides by minus 1. So we get minus 3x plus 4y plus 2z is equal to 5. So when we compare it, we get a is equal to minus 3, b is equal to 4, c is equal to minus 2, d is equal to 5. And we need to reduce it to the vector form. Vector form of the equation of the plane is r vector dot a I cap plus b j cap plus c k cap equal to d, where d is non-negative. We calculated already a, b, c and d value, so we can substitute it. When we substitute it, we get the vector form as r vector dot minus 3 I cap plus 4 j cap minus 2 k cap equal to 5. Here d value is positive. So we got the perfect vector form. I hope you understand this question clearly. Now we will move on to next question. If vector equation of the plane is r vector dot 4 I cap plus j cap minus k cap is equal to minus 2, write it in the Cartesian form. Cartesian form is, you know that Cartesian form of the equation is ax plus by plus cz is equal to d, where d is a non-negative number. But here d is a negative number. Hence, we multiply both sides by minus 1. So r vector dot minus 4 I cap minus j cap plus k cap is equal to plus 2. When we compare it with the general vector form, we get a is equal to minus 4, b is equal to minus 1, c is equal to plus 1, d is equal to 2. Now we got a, b, c and d values, so we can write it in Cartesian form easily. Cartesian form is ax plus by plus cz is equal to d. Just we are substituting the corresponding values. So we are getting the final answer. I hope you understand this problem also. Now we move on to next question. Find the Cartesian equation of the plane. Here vector equation is given. R vector dot s minus 2t I cap plus 3 minus t j cap plus 2s plus t k cap is equal to 15. Here d value is non-negative. If you compare it with vector equation, we get a value is equal to s minus 2t, b value is equal to 3 minus t, c value is equal to 2 plus t and d value is equal to 15. Now we need to write it in Cartesian form. Cartesian form is this. Hence, in place of a, we are substituting s minus 2t, x as it is. In place of b, we are substituting 3 minus t. In place of c, we are substituting 2s plus t. In place of d, we are substituting 15. Hence, we got the Cartesian equation. If you are clear with the equations, then it will be very easy for you to solve all these problems. Now we move on to next question. Write the direction ratios of the normal to the plane r vector dot I cap minus 2 j cap plus 0 k cap is equal to minus 16. Here d value is in negative. First it must be converted in positive. So we are multiplying it on both sides. We are getting this. We are comparing this vector form with the general form, by which we calculate what is a, what is b and what is c. Here a value is equal to minus 1, b value is equal to plus 2, c value is equal to 0. Now we need to calculate direction ratios of the normal. During the explanation, we have very clearly seen that d or direction ratio of the normal is ABC. Here we got ABC value. Hence, direction ratio of the normal to the plane is minus 1, 2, 0. I hope you understand this concept. Now we move on to next question. If the equation of the plane is 2x minus 3y plus 4z plus 11 equal to 0, then what is the direction ratio of the normal to the plane? This question is also similar to what we saw in the previous question, and it has to be converted into the general form. Equation of the plane can be rewritten as 2x minus 3y plus 4z is equal to minus 11. Here d value is a negative number. It must be non-negative. Hence we are multiplying both sides by minus 1. We are getting this expression. It is in the form of Cartesian. So we are comparing it. Direction ratios of the normal is A, B, C. Here when we get when we compare it, we get A is equal to minus 2, B is equal to 3, C is equal to minus 4. If you need further clarification about drs of normal, please go back to the formula, the equation derivation concept, where you will get clear idea that always drs of normal is denoted as A, B, C. Right? Now we move on to next question. Write the direction cosines of normal to the plane. Here they are asking direction cosine. Using this we can only calculate direction ratio. But in vector chapter we learned how to convert direction ratio into direction cosine. We will apply that concept. Now Cartesian form is ax plus by plus cz is equal to d. So when we compare it, we get a is equal to 3, b is equal to 4, c is equal to 12, d is equal to 15. These are direction ratios. But in the question they are asking direction cosine. So we have to apply vector concept. As per vector concept, direction cosine can be calculated as L is equal to A divided by root over of A square plus B square plus C square, M is equal to B divided by root over of A square plus B square plus C square, N is equal to C divided by root over of A square plus B square plus C square. So we are substituting it and we are calculating. Finally we got the direction cosine of the normal as 3 by 13, 4 by 13, 12 by 13. I hope you can understand this question easily. Now we will move on to next question. Find the vector normal to the plane. Here plane equation is given. Now we need to find out the vector in the normal vectors. So normal vector is a vector which is perpendicular to the given plane. So first what we need to do is we need to find out the drs of normal using this. When we calculate drs of normal, that is direction ratio of the normal vector, then we can easily write it in the vector form. It is in the Cartesian form. When we compare it, we are getting a value as 2, b value as 1, c value is equal to minus 3, d is equal to 1. When we know the direction ratio of one vector, we can easily write its vector, that is a I cap plus b j cap plus c k cap. Hence in place of a b c we are substituting the corresponding value. We are getting normal vector. If you are very clear with vector concept, then it will be very easy for you to solve this problem. Now we move on to next question. Find a unit vector normal to the plane 2x plus 3y plus 6z is equal to 4. Here plane equation is given. Using this we need to find out normal vector. When the vector is given, you know how to calculate unit vector. This concept also comes under chapter called vector algebra. Now we will calculate direction ratio of the normal vector. When we compare it with Cartesian form, we get a value is equal to 2, b value is equal to 3, c value is equal to 6, d value is equal to 4. So n vector can be written as 2 I cap plus 3 j cap plus 6 k cap. Now we are asked to find out unit vector. Unit vector means n cap is equal to n vector divided by modulus of n vector. So we are substituting it and we are solving it. I hope you understand all these questions clearly, because you already learnt vector algebra and the 3D plane concept is also very easy. Hence you can understand all this problem clearly. Thank you students. Thanks for your cooperation.